Hello everyone, this is Miss Chelsea and today we will be discussing groups and regions of the periodic table. Our question of the day is, what are some patterns in nature that you already know of? Our standard of the day is SC1G, develop and use models including electron configuration of atoms and ions to predict an element's chemical properties. Do you see all of these blue elements? They are all metals. They are shiny, malleable, meaning bendable, ductile, meaning you can stretch them and turn them into wires. They lose electrons when bonding, and they conduct both heat and electricity. The following are all examples of metals: mercury, Hg, gold, Au, copper, Cu, gallium, Ga, aluminum, Al, and bismuth, Bi. These elements in green are all metalloids. They have properties of both metals and nonmetals. So metalloids are shiny, they're brittle, which means they break easily. They are moderate conductors of electricity. That means they conduct some, but not as much as metals. And they can either gain or lose electrons when bonding. Metalloids include silicon, Si, boron, B, antimony, Sb, and arsenic, As. The pink elements are nonmetals, meaning they are dull. When they're solid, they're brittle. However, not all of these are solids at room temperature. They do not conduct heat or electricity, and they gain electrons when bonding. Most nonmetals are gases at room temperature. These include hydrogen, nitrogen, oxygen, fluorine, chlorine, and all the members of group 18. Some solid nonmetals include sulfur, S, and carbon, C. Now, the groups or columns of the periodic table have different names. For example, within the metals, you have the alkali metals, here in blue. They are in group 1. They each have one valence electron and are highly reactive. They quickly oxidize in air and tend to form strong bases. Group 2, here in purple, are called the alkaline earth metals. They tend to be moderately reactive, have two valence electrons, and also form strong bases. Groups 3 through 12 are the D block. They are called transition metals. These metals have multiple oxidation states, which means they can lose different numbers of electrons. They form colored solutions and tend to be hard, tough metals. At the bottom of the periodic table, you will find two groups that form the F block. One is the lanthanide metals, which are rare earth metals that are soft and malleable and oxidize in the air. These are shown in purple. The other set of F block metals are the actinide metals. These tend to be radioactive and oxidize in air. They are shown here in this dark bluish color. Now, all of the metals on the right side of the periodic table, so from group 13 on, but still below the metalloids or stair-step elements, are called other metals. They are shown in this dark bluish color. All metals have these properties. They tend to lose electrons, forming positive cations. They are shiny. Another word for shiny is lustrous. They are malleable, or they can be bent. They are ductile, meaning they can be stretched into wires. And they are good conductors of both heat and electricity. Now, the metalloids in light blue are somewhere between metals and nonmetals. They're also called the stair-step elements because they form a staircase. These elements can be shiny or dull, and they are somewhat conductive, but not as much so as metals. Group 17, shown in purple, are called the halogens. They tend to be highly reactive. They have 7 valence electrons, so they usually form anions or negative ions with a -1 charge. They are diatomic in nature, meaning they naturally occur as pairs of elements in a molecule instead of single atoms. They are also poisonous. Group 18 in this pinkish color is called the noble gases. They tend to be very inert or unreactive because they have a full valence shell, which means that helium has 2 valence electrons and all of the others have 8. Other nonmetals include hydrogen and all of the nonmetals above the staircase or above the metalloids. They are brittle if solid, and they can be gas or can be solid. They tend to be non-conductors and gain electrons, forming negative anions. The s block on the left side of the periodic table is 2 elements wide because the s orbital holds a max of 2 electrons. The p block on the right side of the periodic table is 6 elements wide because p orbitals hold a maximum of 6 electrons. The d block in the middle is made up of the transition metals. It is 10 elements wide because d orbitals hold a maximum of 10 electrons. A d shift occurs due to 4s orbital having less energy than 3d. So even though titanium is in the 4th row of the periodic table, it's actually has electrons in the 3d orbitals. The F block at the bottom of the periodic table is 14 elements wide because the 7f orbitals hold a maximum of 14 electrons. They are separated from the rest of the periodic table to make the table print nicely. However, these occur right after lanthanum and actinium. Lastly, let's discuss the diatomics. So, notice how H, N, O, F, Cl, Br, and I are all in light blue. These 7 elements make a number 7, plus H of course, and they always come in pairs. That's why they're called diatomics. So you won't see a single atom of hydrogen lying around. You'll see a molecule made up of 2 hydrogen atoms, H2. You'll also see N2, O2, F2, Cl2, Br2, and I2 when they are in their elemental forms. So that's all for today. Go ahead and try the show what you know questions to see how much you understood from this lesson.